And joining us now here on the program, we are looking at a new study that was conducted in partnership between USDA and the University of Missouri, looking at water and carbon cycles to identify sustainable farming practices that are aimed at helping our staple crops like corn, soybeans, as we see the climate continue to change and help out our crops during extreme weather conditions and more. And here to talk about this with us, one of the authors of the study. He is joining us today, USDA hydrologist Adam Schreiner-McGraw. Adam, great to have you on the show today. Thanks so much for joining us.
Yeah, thank you. I really appreciate your interest in our work.
Well, I thought this was fascinating stuff, and I thought a lot of our farmers and ranchers would love to hear about this work as well. And I kind of set it up there, but can you just to start talk a little bit about the reasoning behind this study and why you guys felt this was important to do?
Yeah, so we had set up these instruments to measure water and carbon fluxes in 2015. So we have been collecting kind of a long data set by now. And these measurements are really useful because, as I'm sure all of you listening know, carbon uptake is essentially plant growth. And then, using water is how plants accomplish that carbon uptake and growth. And so we're really measuring plants growing and the most important processes in that. And so this study was a first look at that data that we've been collecting for 6 years. And we wanted to understand how these different agricultural ecosystems that we're looking at behaved at an annual scale. And we were also very curious if our aspirational system, which includes cover crops, no-till, and an expanded crop rotation, had better resilience than conventional business as usual system, which is conventional tillage, no cover crops, only corn, soybean. And we were also comparing them to a natural prairie site and trying to see if this cropping system with more diversity behaved a little bit more like a prairie that obviously has a lot of plant diversity within it.
Well, a lot of great insight there. And obviously, we're seeing a lot of changes to climate, temperatures, rainfall patterns, etc., that are having a pretty substantial impact on our crops and our development. And, I think about development of new genetics and much more out there to try and help combat some of these changes. What did you find in the research that growers really need to think about here as we move forward, Adam?
Yeah, so the one thing I want to be clear, this is an initial study. We have a lot more work to do. I'm going to be hiring a postdoc to help us expand our analysis across the whole country. But with that being said, our preliminary results were pretty fascinating. First of all, we found that this prairie site, which has more than 100 types of plants, was very resilient to extreme weather conditions. We think that's likely because as some plants, like, if the temperature gets really hot, some plants will get stressed out, but then some other plants will thrive in those conditions. And so overall, this mixture of plants balance each other out and become very resilient to extreme weather conditions. We used our measurements of carbon flux to measure when the plants were growing and how much they were growing throughout this 6-year period. And we found that when the weather was extreme, we looked at dry conditions, low soil water content, hot conditions, and then conditions when the atmosphere is really demanding a lot of water, which we call high vapor pressure deficit. And we found that our cropping system that had a larger crop diversity behaved similarly to the prairie. It wasn't quite as resilient to these extreme weather conditions, but by having more crops, there's a wider range of acceptable conditions. And we believe also that the soil is a little bit healthier in this system, and that played a role as well.
Mm-hmm.
But the big thing that we're thinking is this diversity of crops. So for example, if you plant winter wheat in one year and there happens to be a drought during the summer, your crop's going to be okay because the wheat would have been harvested before the drought hit. So over the long time period, if you can take advantage of different growing seasons, different crop preferences, you end up with these agricultural systems that are more resilient to weather conditions.
That is a fascinating thought to consider. Definitely, I think something for a lot of folks to consider, Adam. And I wonder too. we're seeing kind of an interesting weather pattern already here in 2023 that's trended drier. I have to think, you could correct me if I'm wrong, I have to think that's maybe a good example of some issues that we could face, down the road here as the climate continues to change, Adam.
I think it is. The big thing, there's not a whole lot of evidence and from observations and models that, at least in Missouri, that it's going to get drier, but there's a lot of evidence that's going to get hotter. And so, excuse me, if it's hotter, then the atmosphere can pull more water out of the crops. And then another challenge that we're facing is that the rainfall patterns are shifting. And so we do have observations from long-term rain gauge networks that the rainfall is changing when it falls during the year. We're seeing more rain during the springtime and less rain during the summertime, which obviously makes it very difficult to grow crops because in the spring, when you want to be planting, the fields are too wet to plant. And then during the summer, when this corn and soybean need their water to grow, there isn't water available. So that's one of the big changes that we're seeing that is making things difficult. Then the other change that we're seeing is, and there's a little bit less evidence for this because I think it's more challenging to observe, but that the rainfall is coming less frequently in more intense storms. So the total rainfall throughout the year ends up being pretty similar, but it comes, exactly like I said, in these big intense rainstorms that then there's a couple weeks of dry periods between them, which obviously then makes it challenging for agriculture because during those dry periods, you're relying on the soil water that was stored up from the rainstorm.
Well, you alluded to this a little bit. Can you share any more thoughts on just some maybe management practices that you guys found through the study that can help farmers as we see our climate continue to change? Can you touch on anything else there for us, Adam?
Yeah, so in this study, and again, it's fairly preliminary, but in this study, we found that the crop diversification was really helpful. Another thing that I've seen a lot of evidence for from other researchers in my research unit and across the Midwest is that cover crops are really useful for a couple reasons, especially when we're thinking about water resources. One, they prevent soil erosion. And so then over the long term, you end up having thicker soil, which means that soil can hold more water. So if you get one of those large, intense rainstorms, the soil is able to hold that water in it. And cover crops also then increase the amount of organic matter in soils, which increases their ability to hold water further. So I would say cover crops, at this point, there's quite a bit of evidence that they help build more resilient agricultural systems.
Great thoughts, great insight. Before we let you go, Adam, any final thoughts you want to share with us about the study? Anything you want to reiterate for farmers listening in? Anything else you have for us here today?
Not really. The main thing, we're going to be continuing this research over the next couple of years and expanding it out across the entire country. And so, I hope in a couple of years we'll have a lot stronger results to share with you guys. And I'm excited to see what we find.
Well, we'll have to check back in as you get more results and continue your work on this study. And we appreciate the time here today with that USDA hydrologist Adam Schreiner-McGraw. Thanks for joining us so much, and we appreciate it. We'll talk to you again soon.
Sounds great. I really appreciate your time. Thank you.